Hey guys, Tim here from PWC Family. In today's video, I'll be responding to some comments I've had on the channel about sound systems. So, you've decided to put a sound system in your car. You've collected all the equipment and now you've got to run power from the front of the car to the back of the car. Now you go to your local audio store or whatever and you ask what cable you should use. This is what they recommend. It's zero gauge cable. It's like nothing you've had in your car before. This is the thickest cable you can find for audio. Now, they say it's good for 300 amps. So you say, all right, I'm going to power it with this 300 amp fuse. But is it really that simple? That's what we're going to be discussing today in this video. Just keep in mind that what the people say at the shop might not be what the manufacturer measured this cable to handle. It might be 300 amps, but that's at ambient temperature. You got to keep in mind that you might be running this through your engine bay, which is way above ambient temperature. So if you do run this through your engine bay, it might be only 200 amps or 250 amps. This doesn't have to do much with the fusing, but I thought I'd just cover it. How do I select a fuse? You've got to choose the smallest fuse possible in relation to your system. For example, my system is about 180 amps, added everything together at max output. So, I'm going to choose the next size up in the mega fuse, which is 200, just to be safe. Some people put 250 just to give them a little more breathing room. But why would I put a 200 amp fuse if my power cable can handle 300 amps? Well, it has to do with the way fuses work, which I'll explain now. What is this fuse made of? Well, inside this fuse is an element that at a certain temperature burns and opens a circuit. The temperature is achieved by putting a certain amount of current for a certain amount of time through this fuse. But this is inaccurate and a bit slow. Compared to, say, electronic protection, which is a current sensor, like this tone meter, and it senses the current going through this cable and it talks to an electronic protection relay, which can be programmed for, say, 200 amps for 0.1 seconds. And as soon as it goes over that, bang, it's done. It opens a circuit and there's no power going through it, compared for waiting for the fuse to burn. Why isn't this used everywhere in cars? Well, compared to a fuse, electronic protection is quite expensive. And it takes up a lot more room. And in most cases, a fuse is just fine. Why is this fuse inaccurate though? How inaccurate is it? I'll show you this on a chart now. Okay, so I've got the data sheet up. It's time versus current characteristic curves. As you can see, we've got the different curves for all of the fuses. We've got time in seconds on the y-axis and current in amps on the x-axis. Now, this is what's called a logarithmic chart, which means, for example, the x-axis, it goes 10 amps, 20 amps, 30 amps, and then when it gets to 100 amps, it goes 100 amps, 200 amps, 300 amps, so on and so forth until you get to 10,000 amps. Same with the y-axis, it goes 0.1, 0.2, 0.3 seconds, and then it gets to a second. It goes 1 second, 2 second, 3 second, so on and so forth until it's 10,000 seconds. Now, we're going to pick a 200 amp fuse and we're going to see if it intersects with 200 amps on the logarithmic chart. So let's go 100 seconds, 100 amps, 200 amps. Follow this line up, see if it intersects with the blue line. And as you can see, it doesn't intersect with the blue line. So even at 10,000 seconds, it doesn't trip the 200 amp fuse. So, expecting a 200 amp fuse to blow on 200 amps is unrealistic. In fact, fuses are designed to blow at a much higher current than what they're labeled to be. So let's just say you have a fault current of 1000 amps. So we go to 1000 amps, we follow it up until it intersects with the blue line. The blue line, we go to the left, 0.3 seconds. 1000 amps in 0.3 seconds can trip a 200 amp fuse. That's pretty good. So now is the matter of figuring out how to calculate what the fault current will be on your battery. And I'll show you how to do that now. So this is just a cheap battery tester, and the information you need is the battery voltage and the internal resistance. So for this example, the voltage was 12.54 volts, and the internal resistance was 4.8 milliohms. So I've just got this Ohm's law calculator, and Ohm's law is voltage equals current times resistance, and we want to calculate current. So we'll rearrange it to current equals voltage divided by resistance. So I've put the voltage as 12.54 volts, and the resistance I put as 4.8 milliohms. And it's come up with about 2600 amps of current. That's fault current. That's not taking into account the cables from the back of the car. This is just from battery terminal to battery terminal. So to put it into perspective, we've got more than double the 1000 amps we need to blow the 200 amp fuse in 0.3 seconds, which is a really good safety margin. And even at 180 amps of maximum demand, a 200 amp fuse is more than enough, even though I have a 300 amp cable. I hope you guys enjoyed this video and found it informative. Clearly I haven't taken into account everything, as this was only supposed to be a basic guide on how to choose the correct fuse for your system. Now there will be people that say, oh, you can use a 500 amp fuse or you can't use a 500 amp fuse, but now you'll be able to make an informed decision and find the right fuse for your system. Thank you for watching this video. Don't forget to like, subscribe and turn on notifications. And if you have a video idea, please let us know in the comments below.